this video and the next, we will be combining our knowledge of polygons and circles. We will be discussing inscribed and circumscribed polygons. The first thing to do is to differentiate inscribed and circumscribed polygons, and later on, we will solve problems involving inscribed and circumscribed polygons. So what are inscribed polygons? A polygon is inscribed if all of its vertices lie on the circle. The first figure is an example of an inscribed polygon, while the second one isn't, because one of its vertices does not lie on the circle. You can actually describe the inscribed polygon using two equivalent statements, which only differ in terms of the subject. If you focus on the polygon, you say it is inscribed in the circle, which is like saying it is inside a circle. Meanwhile, you can also say the circle is circumscribed about the polygon, which is like saying the circle is circum or around the polygon. This brings us to a concept that we learned earlier in our first quarter math lessons. Do you still remember the word circumcenter, particularly of a triangle? We are extending that now into a circumcenter of a polygon. From our second description of the figure, which focuses on the circle, we say that the circle is circumscribed about the polygon. The center of that circle, circumscribing the polygon, is what you call the circumcenter of the polygon. Now, please take time to summarize those concepts in your notebook before we proceed to the next concepts. Play the video when you are ready to proceed. Now, let's discuss circumscribed polygons. A polygon is circumscribed about a circle if all of its sides are tangent to a circle. In the first figure, the triangle is circumscribed or around a circle, and all its three sides are tangent to the circle. On the contrary, the second figure, the triangle is not circumscribed around the circle, as one of its sides is not tangent to the circle. We can also derive two equivalent statements from this. We can say that a polygon is circumscribed about the circle, or it is around the circle. It is equivalent to saying that the circle is inscribed or inside the polygon. This also calls to mind what we learned in the first quarter, the end center of a triangle, but again, we are extending it to any polygon. Since now the circle is inscribed in the polygon, we say that the center of that circle is what we call the incenter of the polygon. To further clarify the difference between inscribed and circumscribed polygons, we summarize them using these two figures. Note that if the polygon is inscribed, it is inside a circle and all its vertices lie on the circle. Meanwhile, when it is circumscribed, the polygon is outside the circle and all its sides are tangent to the circle. Now that we have differentiated inscribed and circumscribed polygons, we are ready to proceed to the next video discussing some special inscribed and circumscribed polygons. Please click on the next video on this playlist when you are ready. Of course, we don't forget to thank the developers of the GeoGebra app which I used in drawing the illustrations in this video.